Stop paying for GPT-4's noise. If your application is making a single, monolithic call to the most expensive model and expecting perfect, clean output every time, you are building a brittle application that is hemorrhaging tokens. The problem isn't the model quality, it's the architectural assumption. You assume that one expensive call must handle input validation, primary generation, constraint enforcement, and output cleanup. That's not an application, it's a gamble. The solution is the multi-stage refinement pipeline. You replace that single gamble with a structured assembly line, a series of gates, checks, and stages. This shifts the burden from the one perfect shot to many small, inexpensive checks. The first stage is the gatekeeper. Before hitting GPT-4, you use a tiny, cheap model, or even heuristic checks, to validate the user input. Is it clear? Does it contain enough context? This prevents garbage in, garbage out syndrome at the most expensive point. If the input passes, stage 2 is the primary generation. This is where you deploy GPT-4 with its full power to create the high-fidelity artifact. But critically, you are no longer relying on this output being final. This leads us to stage 3, the quality control editor. This is the most powerful cost saver. You use a cheaper, faster model, or even regex and simple classifiers, to perform post-generation checks. Did the output meet length constraints? Is it logically sound? Does it adhere to JSON schema? If the QC check fails, say, the JSON is malformed or it missed a key instruction, it doesn't crash. It's routed back to the generation stage with targeted, cheap prompts. Refine this output based on X constraint. You correct the error cheaply, rather than regenerating from scratch expensively. Let's look at the implementation logic. In Python, this translates to conditional routing gates. The flow isn't sequential, it's a dynamic graph where the output of one function becomes the conditional input for the next. The true elegance is in the error handling. If the refinement loop fails 3 times, you don't retry endlessly wasting tokens. You gracefully fail to a human-in-the-loop queue, providing context and saving the expensive compute cycles. By implementing this architecture, you aren't just saving tokens on the bad calls, you are drastically improving reliability and cutting down end-to-end latency because your expensive model isn't wasting cycles fixing user errors or formatting garbage. The monolithic call is a liability. The pipeline? That's how you build enterprise-grade AI products that scale profitably, reliably, and cleanly. Stop gambling on GPT-4 single shot, and start engineering the system around it.